Hi, welcome to the fun probability problem solving sections. And today we are going to work the second part of this fun probability problem is find the heads matching probability. And from the part one, we learned we kind of proved the PN, that means MN not match. You can write it as the sum of the two terms, right? So like Pn minus 2 and n minus 1. And the second part is here. This is very interesting. We can also rewrite this term into this nice ways here. Okay, so this is the formula we try to prove, for these formulas here. Okay, so now let's go ahead and go to our whiteboard here. Okay, so here is our whiteboard here. All right, so we are trying to learn the PNs, right? The PN, that means out of the MN, they are none of them matches, right? So PN, if we write it, we can say this is the probability, right? So this is probability zero match. That means everybody got the wrong hat. So the zero match, how do we calculate the probability? We can rewrite this. We can say this is we minus the probability. So at least one match, right? So we know this is a common statistical probability. If it's at least one, you use 1 minus zeros, right? So this is at least one matched. Okay, so then let's start from this one, the thinking part from here. So in here, let's say let E the event I will let the event I so I will say the event I be the events be the event that I people, okay, the I person match. Okay, so then the probability at least one match, I can rewrite as this is the probability E1 union E2 union E3 and and union ENs, right? Okay, so union EN. So let's take a look at some special case here, right? So let me change the color. So for the special case, and we know like, for example, if I have a E1 union E2, all right? So I have a E1 union E2. I can write this as the P E1 plus P E2, then minus P E1 intersect E2, right? From the Venn diagram, we can do that. Let's take a look at another ones here. So if I have a E1 union E2 and the union E3, then we can do this. We can say it's P, the E1 plus P, the E2, and the plus P, the E3, and the minus, so we say E1 intersect E2, then minus E1 intersect E3, and minus E1 E2 intersect E3, right? And then, because this is E1, E2, E3, so it's 2 of them. And the last ones here, we will plus E1 intersect E2 intersect E3 here, right? So from the previous problems, from the previous, the rule, when we first started this union, so now we know how to write this from E1 union to the ENs, right? So we know these ones here, we can rewrite this is first, just like compared to here. So this is I equal to from 1 to N. Then you add each one. See here, this is PEI, right? So then the next things here, you minus here, right? So this is a minus, minus, minus. You have two events here, all right? So that's why I can say this is a minus, right? So this is the summations here. So we will say, okay, so then we will say this is the P, the EI intersect EJ, correct? And then here, you guys, you can see this is 1, 2, 1, 3, 2, 3. So it's for all the I less than J, and it's all the way to the ends here, right? So the next times we know it's a plus, right? So now we can write this into a general form. It's da 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 plus. Then we'll say it's -1. So it's -1 to the r plus 1 terms here. All right. So this is -1 to the r plus 1 terms. And then you are adding here, right? So you are adding like it's the I1 less than I2 less than I3 da 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 is less than IR, right? Then here, your terms here is the EI1. All right, so this is EI1 intersect EI2 intersect EIR. Okay, so because it's like for 3 you have 1, 2, 3, right? So for 4 is 1, 2, 3, 4. So this is our general terms here. All right. So now we are going to use this these formulas here try to help us and try to solve the problems here. Okay, so now let's try to get the formula down here, right? So, okay, so now the next things let's see here. So we'll say here, okay, so let's assume I have R people get the correct head. What's that means? That means I have N minus R people left, right? Okay, so I have an N minus plus R people left. That means, so for those N minus, right, so in here, if the R people get the correct head, so I have N minus R, and so I see here the probability like E1 intersect E2 intersect all the way to the ER is equal to N minus R factorial and N factorial here. Okay, so this is okay, so if you're still confused here, so that means if R people get a correct head, right? So I have here N minus R people left, right? So for this person, we will have N minus R. So this person can choose anyone. So it's N minus R situation. Then this one here, after choose one, this is N minus R minus 1 till all the head is choose. So that's why here, this is the N minus R factorials, right? Because when the N when here, the R match, right? So E1, E2, ER, there's only one situation, right? Then, but the remaining is N minus R. So this is N minus R factorials, right? So this is total how many situations you have here. Okay, so now let's take a look. Now, because we say for the R is really, you have this is NI1 less than I2 less than IR. So in fact, okay, so in fact, you can choose, right? You can choose this I1 intersect I to intersect all the way to the intersect either IRs here, right? So this is just like if that the 1 to R, so now you can choose any of those R to match, right? So what is how many ways you choose it? You have a total is N, right? So total is N, so you choose R. And then, because for every single combination, this is the n factorial, n minus r factorial. All right, so here, this is n factorial, r factorial, n minus r factorial, then times n minus r factorial, n factorial, right? So now you can do just like this is cancel, cancel, cancel. Oh boy, so it's such a good, beautiful formula. It's 1 over R factorial, right? Okay, so now let's see here. So the Pn, right? So we do the P is at least one match, right? So we said at least one match is here. Will just be like the formula here. If you remember, that's the formula we have is this is summation minus and then this one here, right? So, okay, so now let's try to write this one here, okay? So this one will be equal to like we said here, the first term will be like this is the summation PEI, I from 1 to n, right? I from 1 to n minus the summation I less than j, right, all the way to n. So this is a P E I intersect EJ, right? Then we do all the way, right? So then the next term is a plus, so you say I less than j less than k, and then you have a P, E, I, intersect E, J, and intersect E, K, right? Then you go all the way till the last ones we said is a plus -1, the R plus 1. Then this is a summation I1 less than I2 to IR, right? Then here your probability EI1 intersect EI2 intersect EIR. Okay, so now let's take a look. So first one's here, remembers, right? So this is the 1 over R, right? So it's R is, what is we define? R is the people get the correct hat. So this one's here, that means only one person get a correct hat, right? So what is here is 1 over, so what is here is 1 over 1, right? So it's 1 over, so I have n's here. So this is the 1 over 1 here, right? So that's what we have is 1 here. Okay, so here, let's see here, this is 1. Okay. Okay, so so this is ones, right? Because for each one they get the correct values here is what is 1 over n, right? Then the 1 over n you summation n time because this is nothing to do with the i's here. So that is what this is 1. And then in here, this is the summation of two sets, right? So you see here, the summation with the two sets is 1 over 2. So this is minus what? 1 over 2 factorial. Then plus, now this is 3 set. So this is 1 over 3 factorial. Then minus 1 over 4 factorials, right? So it's all the way till we select it's n factorial. So this is negative 1 to the n, right? So for all the n greater than equal to 2 here, because n equal to 1, you have one person is cannot match here. So at least one match. So that's why we say the Pn is equal to 1 minus the probability at least one matches, right? So that's why it's 1 minus, is 1 minus 1 minus 2 factorial plus 1/3 factorial minus 1/4 factorial and the plus to the what? The n factorial and that's 1 to the n, right? Okay, so see here. So now you will get a 1 and 1 cancel. So what you have here? So you will have is what? So this is 1 over 2 factorial, right? And so here, okay, so here, this is the 1 over, this is negative 1 over okay, so now here it will be negative 1/3 factorial plus 1/4 factorial. Then all the way till the end, this will be negative 1 to the n factorial here, right? That's what we proved here. So it's the, it's 1/2 1 over 2 factorial minus 1 over 3 factorial here. Okay, so this in fact turns out to be a very beautiful formulas here. So let's take a look here. If you remember, like we know the Taylor or Maclaurin series, EX series is 1 plus like x over 1 plus x over, so it's x squared over 2 factorial plus x cubed over like 3 factorials, right? So plus x fourths over 4 factorial, right? And so when the x equal to the negative 1, then you can say the e to the negative 1 is equal to the 1 minus 1 plus 1 and the 2 factorial. Then negative 1 to the third is minus, right? So it's 1, the 3 factorial, then plus 1, 4 factorial, and minus 1, 5 factorial, and And so in here, this one and this one cancel. So you will have this one is 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 . So a while ago, we just proved, right? So we said the Pn is equal to 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial and minus to the negative 1 to the n factorial. So I know these ones here can be approximately by the value e to the negative 1, right? So it's very close, especially when when the n get into the big, right? So when n to get big, and then this approximation will be very close. It's very, very beautiful. So that we know that the pattern, none of the match is over 1 over e. Okay, so it's very beautiful, beautiful formulas here. All right, that's it. I hope you enjoy the, these proofs here. Okay, so the things here, the key things we use is this is the formula we use here, and then the other things, the key things we say here is this ones here, right? So or zero match is equal to 1 minus at least 1. So this is the at least 1, the purple one, right? All right, that's it. Hope you enjoyed it. Have a good day. All right, okay, bye-bye.